Okay, welcome to lecture number 34. In lecture number 33, we have seen two theorems of triangle inequality and two applications. In the homework of lecture number 33, you have 9 problems, and the 8th problem is discussed in lecture notes of 34. That is another important property of trapezium. If the two midpoints of non-parallel sides are joined, then that length is average of the two parallel sides, and midpoints of diagonals are joined, then that length is difference of two parallel sides divided by 2. Okay, so you can go through the solutions and their converses in the lecture notes of lecture 34. But the other part that of lecture 34 that we are going to discuss now is basically we are getting into finding out different areas. Now, finding out area of any region is very important, and therefore we need to develop the formulae for finding out the areas of geometric figures very systematically. And we have to start with why is area of rectangle length into width, and this question we have to ask ourselves, and then if we could answer this successfully, then we can use area of rectangle to find out area of triangle, half base into height, and then for trapezium, rhombus, and maybe eventually area of circle. So the first discussion is going to be what is area of geometric figure and how do we measure it. So now it is assumed in this discussion that two congruent figures will have congruent area, I mean equal area. Area is a number, therefore it is equal. Figures are congruent. So two congruent figures have equal area is the assumption. This is a postulate which we cannot question and has to be assumed true. Now, the first question that we are asking ourselves is that suppose a rectangle is given to us of side 3 and 2, then why should be the area of this rectangle equal to 6? We have been using it so far, but we have not really asked this question, why is it 6? And whenever you are measuring something, measurement is always a comparison process, and you need to compare your quantity with the standard quantity that you refer to and say my quantity which I am measuring now is bigger or smaller than the standard. Therefore, measurement is always a comparison process, and we need to have a unit of measure for performing any measurement. Suppose a new quantity like temperature is being discussed and we do not know how to measure temperature, then what must have been done is the reference has been created. The water starts boiling at one particular temperature, let us call it as 100 degrees centigrade. Water becomes ice, we call that temperature at 0 degree. So with respect to these two temperatures, what is the temperature of the city that you are living in, etc., can be compared and found out. So measuring temperature is a comparison process, and for reference we may take temperature of boiling water or temperature of ice as a reference temperature. Similarly, we need to have some reference for measuring the area, and if I want to measure this area, maybe I will take reference of square, maybe 1 unit square whose length is 1 unit and width is also 1 unit, and then I will check how many unit squares fit into this diagram, and then I will realize that there are 3 unit squares column wise and 2 unit squares row wise I can fit into it. Therefore, there are 3 column wise 3 unit squares, row wise there are 2 unit squares. Therefore, total unit squares are 6. Area of each unit square is 1. Therefore, total area is 6 into 1 is equal to 6, which happens to be equal to 3 into 2. So if the sides of the rectangle are integers, then it is easy to create a unit of measure and put those squares into the rectangle and find out how many rectangles lengthwise we can accommodate, how many rectangles widthwise we can accommodate, and therefore total number of rectangles into area of each rectangle will be the total area of the figure. Now suppose next challenge will be, suppose you have little bigger 3.2 by 2.4 rectangle, and we want to find out the area of this rectangle, and we have been told in school that it is also 3.2 into 2.4. But why should it be 3.2 into 2.4? The reason is, now we have unit of measure, but the unit of measure is too large, big unit. So we divide this unit of measure into 10 equal parts, lengthwise and widthwise. So we create basically one tiny unit of measure whose side is 1 by 10 and width is also 1 by 10. Therefore area of this tiny square is 1 upon 100. Okay, and then we perform the same procedure. If I start putting tiny squares column wise, how many tiny squares I will put column wise? Column wise I will put 32 tiny squares. Row wise I will put 24 tiny squares. Therefore total tiny squares will be 32 into 24, whatever that number is, and area of each tiny square is 1 upon 100. Therefore total area is equal to 32 into 24 into 1 upon 100. But then this algebra tells us that you need not have to do it like that, and it is okay if you do it 32 by 10 into 24 by 10, which we say 3.2 into 2.4. And yes, therefore ultimately it becomes length into width, and hence for rational lengths, these were integer lengths, we have rational lengths. For rational lengths, area of rectangle would become length into width. Now suppose we have one more digit here, 3 or 5, then what do? We make 100 parts of our unit square, take one tiny part, and then this 1 upon 100 will become 1 upon 10,000, and area of each will be 10,000. You can distribute 100 to each two of them and again do the same expression. That is how the length into width formula for area of rectangle is proved for natural numbers and integers, side length. Now in this lecture we are not going to discuss that, but if the rectangle has sides, say root 5 by root 2, in that case also whether the area is root 10 or something different, because the challenge is now you cannot create unit of measure which will take care of root 2 perfectly. You will be left with some area which you really cannot fit into that unit square. Therefore you will have a challenge of finding out what will be the area of rectangle whose sides are irrational numbers. We will perform that discussion in the next lecture. You also keep thinking about it. Why should be the area of rectangle be length into width even if the sides are irrational? We will discuss the solution in the lecture number 35. Now we have again 10 problems, 10 homework problems which you can solve. Basically this course talks about very little theory and more of homework problems. The student should solve his problems independently, keep thinking about the problem, and therefore he will improve. Okay, so solve these 10 problems. If any doubt, talk to us. Thank you.